Hi everyone, welcome to IoT Show Deep Dive. Shreya and myself are going to be going over Time Series Insights. So we're happy to have you here and we hope you enjoy. Hi everyone, welcome to the IoT Show Deep Dive. Today we're going to deep dive into analyzing IoT data with Time Series Insights. So I am joined here today with Shreya from the Azure IoT team. Hi Shreya, how's it going?
Hey Pam, thanks for having me.
Yeah.
Hey everyone, my name's Shreya Sharma. I'm a PM on Time Series Insights, and I handle our query layer. I'm really excited to show you the new features that TSI is building for RGA.
Yeah, I'm super excited to have you on here, especially to give that full technical walkthrough on working with Time Series Insights. So how about we just go ahead and get started. My name's Pamela Cortez. I'm on the Azure IoT team as well, and I'll be your host for today. So my role is just to be here, listen to Shreya, ask some questions throughout, and then answer your questions and chat as well. So if you have any questions, just put them into chat. We'll be on chat answering those questions for you. All right, so let's jump into the agenda of what we're going to be doing today. So for today, we're just going to give that high level, what is Time Series Insights. We won't spend a really long time in that area, an introduction, because this is a deep dive. We really want to show you how to get started and start building. So Shreya is going to be going through a technical walkthrough. She's going to show you how to work with Time Series Insights Explorer, Power BI, and then our APIs as well. And then she's also going to talk about what's next. What are we GAing? What are some of these features? And then we're going to end with resources. So how you get started, if you have technical questions, where do you go? So yeah, let's go ahead and jump into it. So I'll hand it off to you, Shreya.
So Time Series Insights, just as an overview, is a fully managed data analytics platform that's tailor-made for IoT scenarios. So TSI lets you ingest, store, process, query, and visualize your contextualized data at scale. We offer built-in APIs and a UX for ad hoc exploration and analysis. And TSI also lets you connect to a variety of different tools, such as Power BI. And we offer a JavaScript library in case you want to build your own custom tools. And the best part about all of what I just said is that it automatically scales to your needs, and the pricing is pay as you go. So you only have to pay for what you use.
And Shreya, the one question I get a lot is Time Series Insights only for IoT solutions, or can I use it for, managing other time series data?
You definitely can. So Time Series Insights is optimized for time series data, regardless of the, use case of it.
Thanks, Shreya. Could you jump into the architecture? I think there's a lot of people who are very interested in how you can work with Time Series Insights.
Definitely. So we'll start with looking at the ingestion pipeline, just how you get data into TSI. So devices will send data up to the cloud to IoT Hub or Event Hub. TSI can read from both. And we pass that data to our stream processing engine, which will write in parallel to both warm and cold store.
And Shreya, we have a lot of different types of people joining into this deep dive. You talk about warm and cold storage. For folks who are just starting to work with data and time series data and just data in general when it comes to IoT, could you talk about the differences between warm and cold data?
Yeah, so warm data is meant to house more recent data. So when you provision a TSI pay-as-you-go environment, you get to choose a retention period for your warm store, and we support anywhere from 7 to 30 days. So that means data that's ingested into warm will stay there for that period of time. And for cold store, on the other hand, it's meant for more historical data. So in that way, it becomes the source of truth for your data.
And then for data ingestion, as a customer or developer or data scientist or anyone working with Time Series Insights, how do I access that data?
So the answer is a little bit twofold. You can and can't for some of this.
Okay.
So customers' warm store is managed by TSI and isn't accessible to them for now, except through TSI's own query layer. However, customers have full ownership of their cold store. Now, when you provision your TSI environment, you're asked to create a storage account for TSI to use, and then you have full ownership of that cold storage, and you have access to the Parquet files that are written in there.
Okay, that makes sense. And then what type of data gets put into the, time series model? I'm interested in that part.
So the TSM houses metadata for the devices.
Okay.
The stream processing engine will auto-discover new time series for you, which is new device data flowing in, and then automatically create instances for you in the time series model.
Okay, so how does the time series auto discovery or auto discover these new time series?
So when you provision an environment, we ask users to select a time series ID.
Okay.
The TSID serves as a unique identifier for each device. It's the logical equivalent of having a primary key to a database. And just like primary keys can be a set of attributes, a TSID can also be a combination of up to 3 properties, and we call that a composite key.
Okay, sounds great. I think that was all my questions about at least the ingestion pipeline part.
All right, so sitting above the storage layer is our query layer, which is what I run on Time Series Insights. So we offer 2 sets of APIs, ones that interact with warm and cold store for analysis of time series data, which we call Time Series Query APIs, or TSQ, and we have ones that interact with the model, called Model Query APIs, or TSMQ. The TSI Explorer, which is our out-of-the-box UX offering, and the Power BI connector are built using these APIs, but the APIs can also be leveraged by a user to build their own custom apps.
And then are there differences between the warm and cold queries that people should be aware of?
Yes, thank you for highlighting that. So queries over warm store are made to be more performant and completely free, and queries over cold store are meant to run a little bit slower, largely because they're running over decades of historical data, and a customer will be charged 1 cent per gigabyte scanned for a cold query.
Okay, thank you.
So I do want to talk a little bit more about the future additions to the product as well. And these are things that we're actively building right now or investigating due to large ask from our customers. And the first here is an integration with Azure Digital Twins. And this will allow customers who use both products to author their model once in Azure Digital Twins using Digital Twins Definition Language, or DTDL, and bring that over to TSI for seamless integration with the model. And we're building a job engine that will allow users to perform bulk operations like bulk import of historical data. And lastly, we're investing in how to add what we're calling a calc engine, which provides even more complex real-time event processing on data as it's streamed in. And this will allow users to create what we're calling derived time series, which is a computation combining multiple devices' data.
And for those who are interested in time series insights plus digital twins and how that works, we did have a deep dive for digital twins where Christian and myself, we did have a mention of that and how that would look. So for anyone who's interested, that is on demand. All right. Well, thank you for showcasing the, kind of the back end and the architecture of working with time series insights. What about some core scenarios? And we can keep moving along in our agenda.
So for core scenarios, TSI's most common use cases would be for advanced data exploration, advanced analytics, and operational intelligence. So TSI boasts that a customer needs no upfront data preparation. You can easily ingest billions of events in from IoT Hub and use the tooling exposed to our UX to visually spot anomalies and discover hidden trends in your data. Time series model also helps you view your device data, device metadata alongside your time series data, and our queries are highly scalable, performant, and cost-effective, so you can do these analyses over anywhere from minutes to decades worth of data like that. And all of this together helps you derive operational intelligence and monitor the health, usage, and performance of your equipment at scale. And by enabling connections to other analysis and visualization tools, we give you the capability to view your assets alongside data from your other line of business applications, whether it's in Power BI, your custom apps, or TSI itself.
And I'm looking at your first bulleted point, and it talks about that there's no data preparation. So does that mean you don't need to define a schema, or could you give a little bit more information there before we jump into you giving a demo?
So TSI will dynamically read in and infer your schema as it ingests data for each device. So if your device is sending properties with decimal values, we'll store it as a double for you without you having to tell us. If it sends true or false values, we'll store it as a Boolean. For more information about all the details with type inference and guidance around some best practices is available in our documentation.
Okay, perfect. And we'll share a link at the end of where the documentation is. So I'm excited now for us to jump into seeing a demo of Time Series Insights.
So before we dive in, I just want to highlight some upgrades in our ingestion pipeline that we believe will really help our customers. Another thing we can do to lessen the repetition is batch the events by ID efficiently in an array. So TSI will flatten and create multiple events from one object for you. And you can batch by ID or by timestamp, and in this case we've done by ID. But I do want to point out that if you choose to do this, it will change how you specify your TSID or your timestamp property when you're provisioning your environment. Now in this case, the TSID will remain the same, but as you can see, the timestamp becomes series.timestamp. More information on all this, the new flattening logic, and TSI selection guidance is also available in our docs.
Okay, perfect. So I noticed that, from without batching and with batching, there's definitely size changes. So it looks like there's a cut down in the event sizes. Is there any benefits to that? Is maybe like in cost, or what are some of the benefits of actually cutting those event sizes down?
Right, you're absolutely right. It is cost. So customers are charged for the amount of data processed by the ingestion pipeline. And in this case, you can see the size of the payload reduces down from 655 bytes to 299 bytes. It's almost by half. So for billions of events, this is a great way to cut down on your costs.
All right, well, thank you for giving that overview. So I think this is a perfect time for that technical walkthrough. I'll just ask some questions throughout, but I'm excited to see you go through Time Series Insights.
So for the purpose of this demo, I'll play the role of an operations manager in an agriculture company, all very hypothetical, that owns multiple farms across the US. And I've chosen Time Series Insights as my historian for its analytics capabilities. And I'm looking to analyze weather patterns to make my business decisions that will allow me to plan efficiently and maximize my yields for that year. So let's get started with creating the TSI environment. So you want to go to Azure Marketplace and start typing Time Series Insights. Oops. Hit create. And it's going to ask you for its unique environment name. So I'll say TSI data test. And then you want to put it in the subscription that you like and a resource group. And choose a location, and generally people choose, a region where they live or where it's closest to. This is where your TSI environment is going to be deployed.
Is Time Series available in all regions now?
No, not yet, but we are expanding to more regions based on our customer needs.
Okay, so the regions that are available, they will just show up, but just keep in mind that not all the regions are there. Okay, perfect.
Yep. And then you're asked to choose a pricing tier. So I'm going to select pay as you go. And then we get to the point here where you start to choose your time series ID. And if you remember, time series ID is supposed to be the unique identifier for each time series. So for my setup here, it's going to be station ID, where a station ID pertains to a specific weather station in the States. And as you can see, if you want to add more identifiers, you can add more properties here. And here's where we're going to provision our storage account. So I'm going to call this TSI weather data storage. I'm going to leave it with the locally redundant storage, and I'm going to provision a warm store. So let's choose a retention period of, say, about a month, 30 days.
And then can you provision a pay-as-you-go environment without warm store, or is that just, I'm just interested in if you could just do it without?
Yep, you definitely can. You can also enable and disable warm store after the environment has been provisioned.
Okay.
And so the next step is to add an event source. Now, I've already got an event hub set up that's reading weather telemetry data from the National Oceanic and Atmospheric Administration, which is NOAA. And I'm going to add that here. So let's name it NOAA data. And it's an event hub that already exists in my subscription. There it is. And I'm going to use the listening policy because my environment just needs to listen or read from this event hub. And I'm going to choose my unique consumer group. So you want to make sure that each environment is reading from one specific consumer group and you don't have multiple environments reading from one, because that'll mess up the data routing. And then we get to the timestamp property. So for me, my data is coming in with the timestamp property that's just named timestamp. You hit review and create, and you'll get a notification when your TSI environment is ready.
And I noticed one thing that kind of trips people up is when they're creating a consumer group, they think now that the name is in the box and everything, and then they go hit next. If they don't hit the add button, the create new consumer group, it actually won't save. So you might get an error in deployment. So make sure you hit that one button on the side to make sure it's actually the new consumer group has been created.
Yep. So I'm actually going to switch over to an environment that has a sufficient amount of data for us to work with, so I can show you the modeling and analytics capabilities of our UX. So let me go here. And before we get into the analytics, I'm going to take you to the modeling page. So you click here to see that. And let's just talk a little bit about the parts of the time series model. So instances here represent devices or assets themselves. So in this case, each instance represents a weather station, and instances also house custom metadata about those devices stored in instance fields. So let me just pull one up for you. It'll look something like this. So my instances store the full name, which is Florala Municipal Airport, the time zone, the country subdivision, country secondary subdivision, which just means state and county, the municipality, which is the city, and then the postal code. So this helps me, or this gives me enough context to know exactly where the station is, and none of this data needs to be sent on the wire anymore. And then moving on to hierarchies. Hierarchies define parent-child relationships between instances. So I've got this hierarchy set up here. And if I go back to an instance, I'll show you how to associate one with the hierarchy. So if you go to instance fields, you'll have the option, your hierarchies will show up here, and you can select which ones you want to add them to. You can have one instance associated with multiple hierarchies. All you need to do is fill out these fields that come from the hierarchy itself, and then you'll see in a couple of minutes how the hierarchy is just created for you. And lastly, we have types. So types are housing for variables or calculations that can be applied to any instance that is mapped to the type. So I have a type called station observations here, and all my instances are mapped to this. So in here you can see all these variables. Variables are how we specify which computation we want the query to perform on our raw data. So they can be stored only in the model, or they can be provided inline in some of the query APIs, which we'll see later in this walkthrough.
And then, is there any type of limitations that people need to think about if they're using the hierarchies or the types or variables? Is there a location where folks can get more information on that, or do you have like a kind of a ballpark of what those limitations look like?
Yeah, so there are definitely limitations on the number of instances, hierarchies, types, and variables. All of that content is in the documentation, but the one that I do want to call out is the instance limit. So currently, pay-as-you-go environments support up to 500,000 instances, but by GA, we're going to up this number to 1 million.
Okay. Yeah, that's a lot. So I'd be very interested in how many of the customers and partners using Time Series Insights get to 1 million, because I can imagine, there's so much data out there. So I could see people, getting to those high numbers.
Mm-hmm. So I just want to show real quick the kinds of computations that TSI allows you to do. So we have 3 types of variables, numeric, aggregate, and categorical. Numeric variables allow for basic computation or scalar functions on numeric data types like doubles and longs. So here I'm doing a computation that's converting my Celsius values to Fahrenheit. Let me close out of this. Aggregate variables allow for a range of aggregations on any data type. So a simple aggregate could be count. Let me show you what that would look like. So you go here and you can choose a function here. And the categorical variables are built to view state data or discrete signals. And let me show you a pretty cool example here, if I can click on it. Okay, there we go. Using some new scalar functions that we introduced. So IFF is basically an if-else function. It evaluates a Boolean argument and then returns either the second or third argument. So you can nest them as well, like I've done here. So this is basically saying if the heat index value is less than 41, do this. And if it's not, do this. And then within here, I'm also doing an if-else. And as you can see, it's going to return one of these 4 values as a string, which I then map to these categories. So this is telling me, based on the heat index, whether it's safe to go outside or not, the heat caution level. So let's go over to the Analytics tab to actually see this stuff in action. So say my company owns a bunch of strawberry farms out in, say, San Jose, California. So let me look for California here. And San Jose is in Santa Clara County. There we go. I can expand this. So there are many areas of farming that are impacted by weather, such as irrigation, pest and disease control, and fertilizer application. So to determine a potentially costly decision for myself, such as when I should irrigate my crops and how much water I should use, I would need to watch for adequate amounts of moisture and temperature. So to chart that data, I'm going to use relative humidity and the temperature variable I just had. So let's look here. So as you can see, as temperature rises, relative humidity falls and vice versa. So I want to water my strawberries sometime in the morning when the values aren't too extreme. So I want to look for what the average value is here. Now, I could sit here and calculate these individually, but there's a much easier way if I brush over and look at chart statistics. So this will tell me the average relative humidity during the morning in the past day was 21 degrees. And the average temperature was 60 degrees. So I can drop a marker and drag this over to around that area. So it's about 60, about 21. And this is when I want to water my crops. These are usually very complex calculations that agriculture companies probably have to do, but I'm just eyeballing and dropping a marker there. So when considering when to apply pest and disease control sprays, wind forecasts play a role because crop dusters or small drone aircraft that spray the pesticide do so from above, and we want to make sure that the wind doesn't make them mess up their targets.
Yeah, that would that would not be fun. Well, I see that. Okay, so you have a view of one day, and it looks like you can go back. What's that view look like for 30 days? And then what is it? How far back can you go with time series insight, especially in the Explorer view?
So this is actually a really great way to show you the performance of our queries. So you can go back as far as you'd like, or as much to see as much data as you have in this environment. So it looks like for me, I've got about a year's worth of data in here so far. So let me start with the 30 days and see where that gets us. Let's go 30 days, 11 hours. So as you can see, that came up pretty quickly. Say we extend it to maybe 365 days. Let's do the whole year.
And I know you said that this particular example, they're showing 1 year worth of data. If you haven't been using time series insights, but you have many years of data that you want to go ahead and import, can you do that with time series insights? And what would be your advice there for those folks who are interested in bringing in data?
So that's actually functionality that we're building right now. We're going to be adding a bulk import function. So you'll be able to go in here and perform a bulk import job.
Okay. Yeah, I could see that being really important for people.
Yep. Let me go back to the past day, say 24 hours. We also have these quick times for your calendar, or calendar picker, to make the lookup easier, and you don't have to sit here and do the whole.
Yes.
Yeah.
Just keep sliding until you get there.
Yeah. So yeah, let's try charting the wind speeds in this area for this farm. So a cool thing we can do is clone the line right here in the well. So you clone this, and then you can change the variable that you're looking at. So let me change it to wind speed. And when you clone, it actually makes it the same color. So I'm going to change it with this color picker. Let's make it, let's make it green.
Okay.
So you want to spray your pesticide when there's little or no wind speed. So let's put this up, and I can add another marker, maybe somewhere around here. You get about 1 meter per second wind. It's not too bad. And there you go. And so once you have a view that you like, you can also save it or share it with anyone who has access to this environment. There are also really cool functionality that we can do with different types of charts. And you can also go in here and time shift your data to look for temporal patterns.
I see you have a view of one of these farms, but what if you wanted to do kind of a comparison across many different farms and different areas? Can you have that view, and how do you do that view in time series insights?
Gotcha. So the easiest way would be to chart the time series that you want to see and then use the swim lanes functionality. So let's look at maybe another farm that's in Los Angeles, that's near Los Angeles. So as you can see, see, you're getting hits that you might not want here, because the way the search works is it looks for these words separately. But if you want to do a full text search, you can put quotes around it, and that'll get rid of all those extra hits that you might not want. So I'm going to chart this one that's near the USC campus. Let's look for relative humidity. Where's my temperature? Temperature and wind speed from these farms. Oh, scroll this up so we can play with the well. Okay, so this is how you choose a swim lane where you'll view the data. So if I'm going to try to place the relative humidities in the same swim lane, the temperatures in the same swim lane, and then the wind speeds in the same swim lane. And because these are from different farms, I'm actually going to try to make them the same color so we can see. And let's leave this one pink. So it's easy to pick out which one belongs to which when you see this. There you go. And you can compare the conditions around both farms and correlate to see the view from different farms. I'll leave it at that.
Okay, perfect. And your markers on there, can you change the color of the markers to tie in with the farm that you have for the markers? Or because when you had that original marker, it was really for that particular farm. But now that you have multiple farms, should you change the markers, or what would be your advice there? How do you know it's just for that particular farm?
So the marker actually applies to the full screen that you're looking at. You can't assign them for a specific time series, but that is really great feedback, and that's probably something we can go add.
Okay. Yeah. I'm just suggesting a feature request. Didn't mean to do that, but if you do have a feature or request for a feature, definitely always reach out to us because we are creating these features based on feedback from customer partners, from all of you, and then apparently internally to our team as well. So definitely reach out through Microsoft Q&A and some other resources that we'll share with you at the end.
Yep. The next thing that I wanted to highlight or show was the Power BI connector. So to use the Power BI connector, you click here for more actions and then go to Connect to Power BI. I'm actually going to open a saved query that I have for my LA farm only. So this is data from the past 30 days. I'm going to leave it at 30 days maybe for this. And so you hit Connect to Power BI and you copy this query to your clipboard. So let's go over to Power BI. Hit Get Data. And these things take a while, but I assume you can cut out the time that it takes to pull this up.
Oh, it's fine because there's plenty of things to ask in the meanwhile. So while you're getting this set up, can you query over cold in Power BI or just warm?
It's a really good question. So Power BI connector only supports warm store today, but cold support is something that we are actively looking to add. So you come here in your custom query, paste it in, hit OK, and let this load.
And
it takes a second.
One of the questions that I've been hearing from folks is, for this Power BI connector, when does it make sense to use the Power BI connector? Because isn't Time Series Insights a way to already visualize that data? So what is that extra benefit of using Power BI?
The extra benefit would be that you get to create reports that you can share out to your organization. You can also view other streams of data within Power BI. So you can load in data from, I guess in this case, my farms, and then also have maybe financial data that's coming in and view them in the same way, in the same space.
That makes sense. I can imagine, especially if you're a big company, not every organization is going to have the need to use Time Series Insights. So most organizations are probably already using Power BI. So having that extra view is really beneficial for the different teams.
Yep. So once you've got your query in here, you can make sure that you're in the report view. And I'm going to add a line chart, just very simple. And then you want to drag your timestamp to the x-axis here. The one thing that you need to make sure that you do is choose _ timestamp here. Date hierarchy is the default. Okay. So you go here, And then I might pull this into values. And you start to see something. Hold on, let me make this a little bit bigger so you can see this. And let me start charting the actual averages that I want to see. And there you go. This is basically the same visualization that's in TSI. You can see this area here. But now you're seeing this in Power BI. And you can set this up so by default we set this is search span relative parameter to true. So that means that Power BI will go in and grab the latest data and make sure that the search span is always relative to the time. So you're always getting the last 30 days, and it's not this specific 30 days. But you can also edit this to false if you want the absolute time. And with that, I'm going to move on to talking about how to use the APIs. So Time Series Insights has 3 APIs. We've got Get Events, Get Series, and Get Aggregate Series. So this is the first one here, called Get Events. This one's actually pretty simple to explain. Get Events is what you would use if you were looking to see raw data, completely untouched as it came in from the event source. So it's what the UX uses when you click Explore Events. Real quick here. Let me go click Explore Events. And this is how we grab the raw data. So I'm going to have something from, I have about a week's worth of raw data here from June 12th to June 19th for a specific TSID, which is my LA farm, and I'm going to set a take of 10. So we run this.
And then what does take mean in this JSON?
So take is how you specify how many events you want to receive back from the API. The max take that you can go up to is 250,000. So as you can see, we go in here, and because I haven't specified specific properties that I want to see, it's going to return all the properties from my event payload. So I'm getting my temperature, my dew point values, the wind direction values, everything that came in.
Is it safe to assume that there is a way where you don't have to see all of the properties, that you could just select maybe 1 or 2 of the properties you actually want to show up?
Let me do that right now. So you can add a parameter called projected variables, or projected properties, sorry. And it's an array of all the properties that you want to see. So here, beautify that again. Oh, forgot a comma. And let's run this. And you'll see only the barometric pressure returned.
That was fast.
Yep. So the next API is Get Series. And it's actually very similar to Get Events in that it works on raw data. The only difference is that now you can specify an inline variable or select one from the model if you have one. So now, remember, variables are how we define the computation that you want performed on a specific property. So here I'm using a numeric variable because the property that I want to operate on is a numeric type. Let me get this authorized while I talk over. So for example, say you have a faulty barometer, and you want it to be offset by a certain value. So I'm going to offset mine by, say, 500 pascals. So I can do something like this, and I can view all my raw data actually offsetted by the value that I need. Use a Get Series. So if we run this, let me pull this back up now. And we can actually compare the values now. So let's see. Before we got 1001 320 pascals, and now we've got 1001 820 pascals. So the offset works.
And I noticed that it says TX or TSX. What is that actually? I know you added some information there, but could you give a little bit more info on what that stands for?
Yep. So TSX stands for Time Series Expression Language. This is basically the syntax that we use to define the different parts of the variable. So let me bring this back down so you can see the full thing. You would need to use TSX to define the value portion of a variable, the filter, and the aggregation.
Okay, thanks.
Yep.
Anytime I see an acronym.
Yeah, it's those 3-letter words. Okay, and the last API we have is get aggregate series. And now this one's fun because we start to introduce things like intervals and aggregations. So I'm going to try to put this as simply as I can. For a specified search span and interval, we're going to return one aggregated value per interval per variable as well. So that might sound a little bit confusing, but it'll make more sense once I run this. Let me make sure the authorization works on this as well. Okay, here we go. So to set the scene, say your sensor sends data maybe once every couple minutes. Now the other two APIs would let you look at and transform those raw data points, but say you wanted a more zoomed out view and you want to see the range of your temperature data per hour, for example. Say you wanted to compute what the min and max values were per hour. So to perform an aggregation like that over time, you would use this API. It's actually what RUX uses every time you chart a variable. So I'm going to show this example with wind speed. And this will return the min and max wind speed for each interval for the search span. So let me run this. And here you go. So these are the left interval timestamp boundaries. Or actually, I should say, so these are the left boundary timestamps for each interval, and these are the values associated. There you go. You can see the range of values for wind speed. The one thing I want to call out is the how to specify which store type to run against. So in the UX, if you run against the yellow region, you're running against warm. So let me go back here. This region here, the yellow region is where the warm store is. So if you run your query here, it's going to hit warm. And if you run it over the gray region, it's going to hit cold. But when you're using the APIs, you have to provide a parameter in your URL. It's called store type. So if you don't provide the store type parameter, we're going to assume that you mean cold. And by default, we'll route it to cold, which means you're going to be charged for those queries. And if you want to use the warm store, you just need to make sure that the search span falls within the warm store retention period. And
do you think that people have to post in that URL, change it there? Is that where they're going to be making that change from warm to store, or is there another location that they're going to change it in?
Yep, you would change it right here. So right now I'm going to run this against warm store. See, it returns pretty fast. But if I try to make it cold store, well, it's not going to return like that much slower, but it'll be a little bit slower if we sat and measured the milliseconds that it took, which I guess we can. So yeah. But yeah, those are our 3 APIs. So I also just want to call out the only limits that we have for APIs are the number of concurrent requests that we can receive. So for warm store, we can receive a max of 30 concurrent requests, and for cold store, we can only accept a max of 20 concurrent requests. But besides that, you can feel free to hit us with as many queries as you'd like. Just to do a quick summary of our items in for GA. So we're going to offer warm and cold storage-based analytics, the 1 million scale, or 1 million instances scale for time series model. We have new scalar and aggregate functions for the time series query APIs. You already saw some in the demo with IFF. We also have time-weighted average functions. We have a revamped UX with scatter plots. Oh, spelled that wrong. Categorical variables, swim lanes, auto refresh, chart stats, saved queries, time shift, and a bunch of other features that I haven't listed yet because it would take up the whole space. We have our Power BI connector and public preview. We also are adding support for ADLS Gen 2, and AED groups, and then just general enterprise readiness related things like regional expansion, security, and scale.
Okay, well, I'm excited to see what's next.
Oh, yeah. So we're adding a lot of new features in data processing. We're going to be reducing the lag and latency. We're going to be adding transforms, also bulk import, which you asked about. And then we have sort of an IoT better together story where we're going to be integrating with digital twins, PnP, and lots of updates in query, maybe an exposure of KQL, dimension-based queries, data deletion, Spark connector, and lots of cool stuff coming for UX as well, like dashboards and process graphics. I also want to mention that we're going to have a plan to migrate from TSI Gen 1 to TSI Gen 2, which we'll be releasing soon. And then a little bit out in the future is going to be TSI on Edge, anomaly detection, disaster recovery, and more SDKs to help people build on top of us.
And I know it's maybe a little too early to ask this question, but when you're talking about migration from Gen 1 to Gen 2, is the thought that we'll handle that migration on our side, or that there's a particular, if you're a customer using Gen 1, that there are steps you're going to have to do that migration to Gen 2? Do we have any insights of how that's going to look? I know it's pretty early, but...
It's a good question. It's going to be the latter. So we're going to have a plan to help customers migrate, and we'll show you like how to find feature parity, or we'll have the full rundown of how to use pay as you go, so that you can continue your operations as you did from TSI Gen 1.
Okay. And then I'm excited about the OPC UA binary, and then also CDM support, mostly because I think Time Series Insights tends to shine, I think, with industrial IoT solutions. So I can imagine that's going to be probably one of the features that was requested the most by the customers and partners we've been working with. So I'm excited to see that. So is there any last things that you would like to say to the viewers right now on any best practices, or just anything you want to share before we jump into the resources?
I think we covered pretty much everything. If there's still questions, like Pam said, feel free to send us a note. We're really excited for customers to onboard onto TSI Gen 2, the pay-as-you-go version, and we're excited to see what you guys build.
All right, so thank you so much. And so let's go ahead and jump into the resource slide. I'll give the kind of the standard resources that we have, and then we also have a link to the Time Series Insights tutorial as well. So if you've first time being on a deep dive, here's some common resources we always tell people about. One is IoT Show. You're already viewing an IoT Show, one of the formats. So I hope you know about it because you're here. But if you want to view kind of update announcement videos, we have what we call IoT Show Classic, where it's really kind of snack bite intros of the new products that are coming, or maybe as a partner spotlight. And then what we have is the deep dives, which is this interactive community events where we could pick different topics every week or every other week based on your feedback. And it's a great way for us to have that open dialogue with each other as well, and answer some of your questions in real time. And then if you're interested in some announcements, and some blog posts. We do have what we call the IoT tech community. That's really Microsoft tech community, and we have a section for Microsoft IoT. So we have Windows IoT, we have Azure IoT, we have Azure Sphere. All of that kind of IoT family is in the tech community. And that really is for you to share your projects, share some of your challenges, or connect with us. So it's a great forum to go back and forth with us and get some fun blog post. And so there's a link for the Time Series Insights tutorial right there that goes through the different things that Shreya was showcasing. And then we have the Microsoft Q&A. Think of this as your place. If you have technical questions, head to Microsoft Q&A. You can still go to Stack Overflow, of course. And then if you have issues on GitHub, go there. But if you have some questions where those are areas that you want to get to our engineers, so myself and Shreya, you can reach us at the Microsoft Q&A, and that is the site that you can find it. And I've also been posting these slides on Tech Community after the event, so feel free, if you're interested in seeing these slides, head over there. So I want to thank everyone for coming, and then everyone who's watching this on demand. Here's some resources for you if you have questions to follow up with us. So thank you again, and huge thanks to our speaker. I really appreciate you giving us that technical walkthrough. You really had a lot of material, so I'm excited for folks to get started. So thanks, everyone. Have a great day.
Yeah, thank you guys.